Good morning, learners and viewers. Welcome to the session of Management of Machines and Materials, MMPC 009. Today we will be talking about Unit 1, 2, and 3. In Block 1, it's related to Operations Management in Overview and Facility Planning. Unit 1 is Operations Management and Overview. Unit 2 is product selection and process selection, and Unit 3 is facilities location. So we will start with operations management. Operation management may be defined as the design, operation, and improvement of the production system that creates the firm's primary product or services. The broad concept of production will be kept in mind throughout, but the apparent emphasis may be on techniques used in the context of manufacturing organization, but one should always be able to extend and apply these management techniques to all types of service organizations. A general concept of operations instead of production will be better include both manufacturing as well as service organizations. Operations either in manufacturing or in service are purposeful activities of an organization. Operations function is the heart of and indeed the very reason for an organization. All operations can be said to add value to some object, thereby enhancing its usefulness. We may define an operation as the process of changing inputs into outputs and thereby adding value to some entity. This constitutes the primary function of virtually every organization. How value can be added to an entity by performing an operation function? There are four major ways. First one is to alter. This refers to change in the form or state of the inputs. This change may be physical, as in manufacturing, or sensual or psychological. Number two is transport. The entity gets value added through transport because it may have more value if located somewhere other than where currently it is. Entity may include people, goods, or garbage. Third one is store. The value is enhanced if the entity is kept in a protected environment for some period of time, such as potatoes in cold storage or food grains in warehouses. Inspect. The value of an entity may be enriched through an inspection as we better understand its property and can therefore take more informed decisions regarding their purchase, use, repairs, etc. Almost every organization, that is of manufacturing, transportation, warehousing, healthcare, education, etc., come within the purview of operations management. System concept in operations management. A system may be defined as purposeful collection of people, objects, and procedures for operating within an environment. Every organization can be represented as a system consisting of interacting subsystems. The features of a system are that these have inputs and outputs. The basic process of the system converts the resources inputs into some useful form of outputs. Depending upon the efficiency of the conversion process, we may have undesirable outputs too, such as pollutions, scrap or wastage, rejections, loss of human life in a hospital, etc. Using the generalized concept of production, which includes services, we can call such system as production systems. You can see over here, this is a conceptual model of a production operation system. Here we see the input, how the process takes place and how the conversion is performed. Suppose for we take inputs. Input can be in the form of land, labor, capital, money. As we move on towards the right, it comes under the conversion process. And then after when the conversion process is implemented on it, so it comes out to be an output, which can be in the form of goods or services. Here we can see that in the conversion process, there are random fluctuations, and that needs to be monitored. And if required, we have to adjust them. And this can only be done when we are going to compare with the actual one and the desired one. It takes resource inputs and processes them to produce useful outputs in the form of goods and services. Now, inputs and outputs. Input to the system may be labor, material, equipment, machines, facilities, energy, information and technology. Other inputs to operating system can be customers in a bank, patients in a hospital, commuters to public transport system, files and papers to an office situation, etc. Productivity of conversion process. This conversion efficiency can be roughly gauged by the ratio of output to input, a term which is generally known as productivity of the system. So hence productivity is output upon input, or we can see that output up divided by input. Management of production system is concerned with the management of productivity. An alternate way of looking at the concept of productivity is to look at the amount of waste generated in the system. Then productivity can be improved by reducing wastefulness, that is, wastivity of the system. This waste is of the following types of the resources. It can be in the form of materials, labor, capacity of machine, time, space, capital, etc. Now, what is the difference between services and goods production? A clear line of demarcation between the products and the services is much less apparent. Almost all the purchases of consumer product involves services as well as the product itself. If you buy an automobile, you not only buy the product but also take the guarantee of the parts and the numbers of servicing of the vehicle. Example of manufacturing systems are production of cement, paper, coal, textile, automobile, TV, machine tools and furniture, etc. While the service system includes telephone exchange, post office, bank, hospitals and cinema halls, etc. Here we can see that it's basically a conversion process or support process is taking place. What are the objectives in operations management? The basic objective of an organization may be to produce the goods or services in required quantities and of quality as per the schedule and at a minimum cost. Quantity, quality, and time schedule are the objectives that determine the extent of customer satisfaction. Various objectives can be grouped as performance objectives and cost objectives. If we talk about the performance objectives, which will be or they are in the form of its efficiency, effectiveness, quality, lead times, capacity utilization. And if we talk about cost objectives, it can be explicit, that is visible cost, which is in the form of material cost, direct and indirect labor cost, and the second one is implicit, that is invisible or hidden cost. That includes cost of carrying the inventory from one place to another. Now, decisions of production and operation management. The process of management. Operation management can be essentially considered as a process of planning, organizing, directing, and controlling. There are different ways in which the production management functions can be grouped for the sake of discussion. These are summarized as classification of decisions. The first way to group these decisions are periodic decisions, which include selection, design, and updating of resources, structures, system, and procedures. Second one is continual decision, which are required in day-to-day operations and control of production systems. Now, we can see over here what are the factors which are responsible for manufacturing and services industry both. If we talk about output, in manufacturing units it is tangible, but in service industry it is intangible. Labor cost in manufacturing unit is fairly low, but on the other side, in the services it is fairly high. Customer interaction is limited in manufacturing, but in service industry it is fairly high. Input uniformity is high in manufacturing, but it is low in services. Output uniformity is high in manufacturing and it is low in services. Quality improvement is fairly easy in manufacturing units, but it is somewhat difficult in service industry. Productivity measure, no doubt, it's easy in manufacturing unit, but it's too difficult. Rather, it is difficult in services. Now, classification of production management decisions. We can see over here, there are two, it is basically divided into two parts. First one is periodic and the second one is continuous. If we talk about periodic, it is basically a combination of four subsystems: selection, design, updating, and operating and controlling. And you can see that a dotted arrows or dotted lines are shown. This is because it's all interrelated. If we talk about the selection part, it is products, processes, equipments, workforce, location, and layout. After the selection, the design comes, which includes again product, process equipments, jobs, wage payment system, operating and control system, and system and procedures. Now, we are into the process. The updation is required. For updating, it involves revision of production system in the light of changing environment or change in model. And on the other hand, this continual, that is operating, controlling, that is setting targets, scheduling, sequencing, inventory control, production control, cost control, and maintenance, because this is all a continuous process. Another way of looking at these decisions may be planning and design of production system and operations and control of production system. The way, the third way to group this is functions of production and operations management. They are planning decision, planning the conversion system, planning the use of conversion system. This involves planning involves aims and objectives and action to achieve them in the organization. Organizing decisions, identifying and grouping work to be done for conversion, structuring of operations, staffing, job and work design, production, operation standards, payment systems, etc. Third one is directing and controlling decision, that is monitoring and control of conversion system in respect of quality, quantity, time, inventory, cost, maintenance. Here we can see broadly we have taken three things, that is planning, organizing, directing and controlling. From the left, from the diagram, we can see that the inputs are there. As you are aware, that inputs are in the or can be in the form of planning. Then the center part of the diagram indicates the conversion process. And on the right, it is organizing. Organizing for conversion, which includes organizing and staffing for operations, job design, that includes production and operation standards, work measurement. Basically, in conversion of input to output, there are three things in between. First one, when the conversion process is taking place, adjustments are there, and the converge after the conversion process, before the output part, you have to monitor it. This is how your production system works. A strategic decision is one which has a long-term impact influences on the larger part of the system and once implemented cannot be undone easily. These decisions essentially deal with designing and planning aspects. Some example of these decisions are product selection and planning. It is related to the decision as what to produce, what products and services are to be offered. Second one is process selection and planning. That is concerning to the choice of technology and equipment and machinery to be used. Process planning includes aspects of mechanization and automation. Third one is facilities location, which means selecting a right location in order to minimize the total production plus distribution cost. Facility layout and material handling. It facilitates material flow, reduce handling cost, delays and congestion, provides good housekeeping, and to facilitate coordination from one department activity center to another. Facility layout planning problems are very important. Proper choice of the material handling equipment such as forklift truck, conveyors, chip crane, electric tools, etc. Related to the decision of layout planning, computer packages developed such as computerized relative allocation of facilities technique, that is craft, computerized relationship layout planning, that is core lab, and automatic layout design program, LDAP, are used. Nowadays, concept of group technology, cellular manufacturing system, that is CMS, and flexible manufacturing system, FMS, have influenced the layout planning and material handling policies significantly. The fifth one is capacity planning. Capacity is the maximum available amount of output of the conversion process and some specified spend. Capacity planning may be over short term as well as for long term basis. If we talk about operations in short term decisions, that includes production planning, scheduling and controlling, inventory planning and control, quality assurance, job and work design, maintenance and replacement, and cost reduction and control. We had monitoring and feedback control. Without monitoring and control, planning may not be effective, and without planning control, may not be effective. Thus, planning and control are two sides of the same coin. What are the different types of production systems? The entire problem of the production or operations management can be visualized as that of managing the material flow in, through, and out of the production system. In general, the more complex, the more characteristics inside the system, the more difficult it becomes to manage the system. On the basis of material flow characteristics, the production system can be grouped into the four categories: mass production or flow line production system, batch production, job shop production, and unit manufacturing or projects. There, what are the different types of the production system? They are basically of two types, that is intermittent production and continuous production. If we talk about intermittent production, it has three subdivisions, that is product production, job shop production, batch production. And if we talk about continuous production, they have mass flow production and process of continuous production. This figure depicts how material flow characteristics of a typical production process. On the left side, we have inputs. Inputs is in the form which has already been discussed. The raw material comes, different processes are performed. It comes into work in process, that is what we call in short as WIP. Again, the operation is performed and it is into the finished goods stage. Then inspection starts. The finished goods space, when the inspection has been completed, it comes into the form of output or product. The dotted line shows how the information moves, and the dark lines with arrow depicts the material flow. And inverted, these triangles basically are storage because raw material has to be stored, work in process is on the shop floor, and finished goods are normally in the warehouses. Now we will start with mass production of flow line production system. In this system, processing of material from input to output takes place in a sequence in a line flow. Machinery is specific, which is used for production with high volume, low variety output. The main problem is balancing and reducing bottlenecks. Examples are car production, chocolate bars, electronic goods, cement, sugar, oil, etc. Second one is batch production system. This is appropriate for more variety and small volumes of output. Outputs are produced in batches and stored. The flow of material is not linear. Here, single machine is used. The basic problem is the designing of layout, allocation of jobs to machines, determining optimal inventory level, scheduling and sequencing of the operations. The example are bakery products, furniture, cloth maker, cosmetics, drug manufacturing companies. Then comes your job shop. This is highly flexible system which can accommodate large variety of jobs according to the demand. The output is of high variety and low volume. Material flow is not linear and complex in nature. No specific rule is followed and first come first serve is followed. Main problem is designing the criteria of processing. An example is tailor shop, cycle and repair shop, etc. Here are some examples. We can find the process. Movie production is a project. Bakery is in batch. Restaurant, batch. University process, batch. Car repairing, job shop. Oil mining, continuous. Production, office tools, if that is repetitive in nature. And vegetarian, it's job shop. The fourth one is unit manufacture or projects, a non-repetitive set of activities directed towards a unique goal within a limited time frame. Project planning, scheduling, and monitoring techniques based on network models such as PERT or CPM can be used for planning and control of such production systems. Examples are building a bridge and development of a housing society, etc. Now we can see what are the different characteristics, merits, and limitation of all these production systems. If we talk about characteristics of mass production, volume is generally large. Product design, the conversion process and the operation sequence are standardized. Machines and equipment are arranged in a layout pattern. Fixed path material handling equipment is used. Limitation and merit is the quality of output is kept uniform. Work in progress is minimum. Control over material cost and output is simplified, and overhead cost per unit is reduced. Examples are electronics, electrical things, clips, bicycles, and container industry. If we talk about batch production system, here a large variety of product is manufactured in lots. Both general purpose machines for producing parts and special purpose machines for assembling the parts are used, and process layout is followed. This combines the features of both flow production and job production. Type work in progress inventory is high, frequent changes in the product designs, no standard sequence is followed. And as far as if we talk about the examples, it is industrial blowers, motors, book printing, machine tools, etc. As far as job shop production is concerned, here, the product manufactured is custom made or non-standardized. Machines and equipment are arranged or assembled at one place. Volume of output is generally small. Wide range and general purpose machines are used. It involves comparatively small investment in machinery and equipment. It is flexible, the most complex system of production. Raw material and work progress inventories are high. Examples are special projects, models, prototypes, custom clothing, jigs, automobile vehicles, overhauling of automobile vehicles and construction equipment sub-assemblies. And if we talk about the unit manufacture or projects, project has a definite start and finish. It has a definite and definable goal. Project passes through distinct activities which constitute project life cycle. As far as merits and limitation are concerned, planning and scheduling of activities and procurement functions are critical. Inventory is mainly concentrated in product itself. Examples are shipbuilding, electric power plant, blast furnace, dam construction, boiler manufacturing, etc. Management of materials in production system. Materials plays a vital role in production process. 60 to 70% cost is of the material, and proper management of it can cost up to 15 to 20% reduction in the cost of the final product. Material management is defined as the grouping of management functions supporting and complete cycle of material flow from the purchase and internal control of work in process to the warehousing, shipping, and distribution of finished products. The primary objective of a company is to reduce the cost that occurs while buying, storing, handling, minimizes wastage of material, transporting, and packaging material. The various approaches of material management are value analysis, purchase price analysis, material handling, inventory control, store management, and waste management. An integrated approach to materials management must look at all the above mentioned problem areas in a coordinated manner with a view to maximize material management effectiveness. Cost, what are the costs involved in materials management? Managing material involves the following cost. Capital cost, it is the cost of material procured, paid by the company to the supplier. Government levies and taxes. Ordering cost involving the cost of tendering, stationery, postages, inspection, bill payment, and delivery that incurred while purchasing materials. Inventory carrying cost or the holding cost involving cost of storage, record keeping, wages to store staff, and payment of insurance cover for maintaining inventory. Then packaging cost, material handling cost, shipping cost. Here we can see the product life cycle. Normally, here also the same thing happens what we have earlier discussed for product A and product B. For product A, you can see that it started from scratch zero. The graph is moving up, growth is taking place. At the top, it is at the maturity level, and now it is coming down, that is in the decline state. And after a period of time, when the product A was almost achieving its maturity level, product B was launched, and similarly, same pattern will follow. Role of scientific methods in operations management, industrial engineering. Industrial engineering is concerned with the design, improvement, and installation of integrated system of man, material, and equipment. It draws upon specialized knowledge and skills of mathematical, physical, and social science together with the principles and methods of engineering analysis and design of to specify, predict, and to evaluate the results to be obtained from such systems. This is the basic definition which is provided by Indian Institute of Industrial Engineering. What is model? Model can be used for representing real life situations, including convergent systems. Model can be mathematical or structural. Large number of model-based techniques have been developed in the subject called operations research, that is OR, which helps in mathematical conceptualization of many decision-making problems relevant to production and operations management. Next one is computers. They help in providing simpler methods for solving different problems, helps in storing data, processing, management information, decision analysis, and communication processes. Behavioral science. This contributes in designing the appropriate organizational structure, design of work, remuneration, and performance appraisal system, supervisor's relationship with his subordinates, organization structure, individual and group behaviors, work habits, and attitude, incentives, part- participation in decision making, and performance appraisal systems. What is the manager's role in operations? There are three basic requirements for a successful company. It must provide a product, which can be a good or a services, that is suited to the company's capability and for which there is a sufficient market. Second one is it provides or it must provide the product with consistently quality at a level that appeals to intended customers and services their needs. And the third one is it must provide the product at a cost that allows an adequate profit and a reasonable sales price. What are the activities performed by operations managers? First one is planning. This includes forecasting, designing products and services and processes, determining the capacity, location, and layout. Second one is organizing, that is job design, determining standards of operations, work measurement, and project management. Third one is implementing. This includes preparation of operations schedule and monitoring and troubleshooting. Fourth one is controlling. This includes inventory control and materials requirement planning. Now, we move on to unit 2, which is related to product selection and process selection. What is meant by product selection? It is a strategic decision consisting of what product is to be produced, in what form, what features, and what number. Whereas process selection includes or decides about the quality and quantity of the manpower, capital requirement, and the choice of processes used for the production. Product selection is a strategic decision, thereby involves other functional areas like marketing, research and development, and as well as the top management area. The product selection process is highly integrative process. This product functions, cost, quality, and reliability are some of the inputs to this decision. The producibility of a product or services measures the ease and the speed with which the output can be produced. Now, product selection processes. Selection of a product comprises of the following methods. First one is research. Product ideas can be thought for the environmental scanning and from group discussions such as brainstorming, etc. Second one is selection. Once the idea is selected, then different objectives and policies are designed which are subject to economic and profitability factors. Third one is development. Here, further development of the ideas is done to make it a reality. Fourth one is design and testing. In this stage, testing of the product takes place to check its technical soundness, brand name, packaging, and performing consumer preferences test. Here, what are the different stages of bringing a new product to the market? How a new product is brought to the market? This is the research, selection, development, and design. Selection of the products. At the research stage, the priority should be generation of new ideas. Consideration of a new idea may generate a better idea, whereas an evaluative analysis introduced early in the process may hamper the creative process of idea generation. Some techniques of idea generations, for example, brainstorming, explicitly prohibit any analysis or criticism of suggested ideas at the idea generation stage. Once a number of potential new product or services idea have been generated, the process of screening them to evaluate and select the next idea is set in motion. This can be explained in two phases. A qualitative phase, where the new product idea is studied in terms of its match with the corporate objectives and the corporate strategies of the organization. The second phase is more quantitative in the sense that potential cost and revenues or benefits generated by the new product are quantified and an economic analysis is performed to establish the economic viability of the new product or service idea. Product development. Product development is the work contributing towards improvement in the existing knowledge by way of improved ideas, systems, and techniques, etc. Product development is considered with modifications or extensions provided to ideas so as to improve the functioning, the cost, the value of money of the product. Development effort improves the performance of the product, adds options and additional features, and even adds variants of the basic product. What is more important, research or development? Development can start when the research has produced a product or services idea which is technically feasible and economically viable. However, greater effort is expended on the development as compared to research in most parts of the world today than it was, say, around 30 years ago. This is partly because the new products, that is, color television, are more complex and require longer to debug and to improve their performance. This could also be true because research has become very expensive and organizations are under the pressurized to commercialize research as early as possible, even before the product or services ideas have been defined and debugged. The trade off between research and development is an important strategic decision for most organizations. Product design. This is defined as visible and tangible expressions of an idea. At the design stage, detailed specifications are provided so that manufacturers can produce what has been designed. This means not only providing dimensional specification, but even specifications regarding the capacity, horsepower, speed, and color, etc. are laid down, and the task of manufacturing process is to convert the design into physical entities, which includes variety of products. There are two distinctly different priorities that can affect the design of a product. The higher the standardization, the greater will be the ease of producing. If the demand for the product or services is strong, then the price is low. Organizations will try to minimize unit costs. Second includes physical characteristics. Third one is performance parameter. A well-designed product should be functional, affordable, good quality, reliable, maintainable, available and accessible, proper appearance, and the timing. The key elements to be considered in product design are function, which is the new design must properly meet the recipient's need and perform the function for which it is defined. Cost. The total cost incurred in producing the new design should not be excessive, else that will affect its demand. Quality. The quality of the new design should be as high as possible within the constraints of the cost. Quantity. Quality can cost the money, and superior quality will increase the cost and reduce demand, whereas inadequate quality will affect the performance and lead to complaints and foreign demand. Reliability. The new design should function normally without failures for the expected duration. The other elements which are also important in a product design, perhaps to a lesser degree, are appearance, environmental impact, product safety, productivity, maintainability, timing, and accessibility. If both product and services design, many alternatives usually exist that will meet the basic function of the output. The design task is to recognize the major characteristics of the demand and to carry out a detailed analysis of the trade-offs available among the various design alternatives so as to meet the needs of the recipient as closely as possible. How the selection of the process takes place. This refers to the issues of selecting the appropriate process form or mix of forms for an organization to produce its output. The details involved in the actual designing and layout of the transformation process, the layout of the workplaces, the designing of the planning and control procedures, the assurance of quality, etc. What are the different forms? It is combination of process form, production of services, product process life cycles, and break-even analysis for process forms. What is the form of transformation processes in terms of project form? If the output of the transformation process is a product, such products are generally characterized by immobility during the transformation. Such operations are referred to as fixed position assembly and can be seen in the production of ships, aircrafts, cost of building, construction of building, and roads. Resources such as man, material, and equipment are brought together to the duration of the project. Some materials are consumed in the transformation process, while others, like equipment, personnel, are redeployed for some other uses at the end of the project. Intermittent flow process. The intermittent flow process is generally suitable when the variety is large and consequently the volumes are low. The transformation process should be able to take care of this large variety and also a manner that the cost of the processing is excessive, even if the final product does not have excessive variety. For example, in manufacturing of typewriter, the intermediate form is still used for the manufacture of components. A large number of different components can be produced on a common set of machines. In a hospital, there is a blood bank, an X-ray department, a pathological laboratory, and so on. The flow through these departments depend on the exact needs of the patient. The intermediate process is especially suited for service industry because each service is offered customized and so each one requires a different set of operations in a different sequence. Continuous flow process. Continuous process form is characterized by relatively standardized outputs and consequently fixed inputs, fixed sequence and operations, and also fixed processing time. As the variation from the output to another is very small, the transformation process is selected and designed to maximize the efficiency of the resources. When only assembly operations are performed on line, such as line is called assembly line. Assembly of many low variety products is carried out using assembly lines, for example, automobiles, television sets, domestical electrical appliances, etc. Then, what is the new technology for continuous flow process? Recent developments in computers applications have had their effect on continuous flow operations as well. The attempt in all this is to increase the flexibility of the production and assembly lines. The first thing is CNC or DNC. Machines and processes which have been automated using some form of electronic systems are said to be use numeric control or NC. In the early NC machines, instructions for machine control were coded on purchased paper tapes so as to read them as per the requirement. In CNC, that is computer numeric control machines, relatively simple programs can be stored in the memory of the computer, and so it is not necessary to read the control tape for every item manufactured. In DNC, that is direct numerical control machines, programs for a number of NC machines are stored in a single computer of large capacity than the type used in CNC. Also, the integration of number of machines and processes by one computer enables a set of machines to work as a manufacturing system with parts scheduling and process monitoring. Robotics. According to Robot Institute of America, a robot is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools, or specialized devices through variable programmed motions of the performance of a variety of tasks. Robots have come in a big way in the tasks of moving, transferring, etc. An industrial robot has three principal components: one or more arms, usually situated in a fixed base that can move in several directions. A manipulator, being the hand that holds the tool or the part to be worked. A third one is controller that gives detailed movement instructions. Robotics is helping continuous flow processes to change over from one output to another, since the material handling equipment, which was earlier designed as part of the production assembly line, can now be implemented or programmed. CAD, CAM, CAE. CAE is basically computer aided engineering. The trilogy of terms standard for computer aided design, computer aided manufacturing, that's CAM, and computer aided engineering, that is CAE. In these systems, the computer aids in the design process by providing different stages or different images of the design product with different views. The computer screen acting as the designer's drawing. Processing industries, that is fertilizers, petrochemicals, petroleum, milk, drug, etc., also use continuous processing. The operations in these organizations are highly automated with very sophisticated controls, often electronic or computerized. The labor equipment are generally low, and the role of the production workers is limited to monitoring. Selection of the process. This pertains to the issue of selecting the appropriate process, form, or mix of forms for an organization to produce its output. This also involves the actual designing and laying out of the transformation processes, the laying out of the workplaces, the designing and planning and controlling procedures, the assurance of quality, etc. Combining of process forms. Most organizations combine two or more of these processes forms to produce different components and the final product. In many industries, including automobiles, domestical, electrical appliances, etc., the components are made using the intermediate form of processing, whereas the final assembly is based on continuous flow processing. Now, we move on to unit 3 that includes, it's related to facilities location. What is the concept of a facility? The concept of plant location has been generalized into that of facility location, since the facility could include a production, operation, or service system. The term plant has been traditionally used as a synonymous to a factory, manufacturing, or assembly unit. This could include fertilizers, steel, cement, rice, milling plants, textile, beverages, refineries, and thermal or hydroelectric nuclear power stations, etc. When does a location decision arise? Whenever the plant location decision arises, it needs careful attention because of the long-term consequences. Any mistake in selection of a proper location could prove to be costly. Poor location could be a constant source of higher cost, higher investment, difficult marketing and transportation, dissatisfied and frustrated employees and consumers, frequent interruption of production, abnormal wastages, delays and substandard quality, denied advantages of geographical specialization, and so on. Once a facility is set up at a location, it is very difficult to shift later to a better location because of numerous economic, political, and sociological reasons. Economic reasons could include total cost, profits, availability of raw material, labor, power, transportation facilities, and market, etc. Social reasons could include employee welfare, employment opportunities, etc. Political reasons could be because of pursuance of a policy of the decentralization, regional and development planning, especially in a developing country like ours. Policy matters like anti-pollution, etc., would have to be given their due considerations. Now, Weber analysis. Alfred Weber analysis was one of the first attempt to base location decisions on some sort of analysis, its imperfections notwithstanding. Besides discussing the importance of transport and labor cost differentials in deciding location, the main burden of Weber analysis is transport cost of raw material, which was least mobile. On the basis of availability, he categorized raw material into ubiquities to denote those available almost everywhere, like sand, water, etc., and localized material having specific locations, which are further divided into pure materials, which contributes nearly the total weight of it to the finished goods, and gross material, which contributes only a small fraction of total weights to the finished goods. It is obvious that ubiquities hardly influence the decision of location. Weber then proceeds to formulate the material index, which equals the weight of localized material used in the finished products divided by the weight of the finished product. We can see that material is the ratio weight of the localized material used in the finished product to weight of the finished product. If I, that is material index, is greater than 1, then the location should be nearer to the source of raw material. And if mi is less than 1, then the location should be nearer to the market. Two site locations for a new factory. Site A is nearer to market but far from the raw material location, and site B is otherwise. Site A is in rural position location with cheap availability of labor, and site B is in urban location with better availability of power. Now, what is the question arises? Which site should be selected? For consideration in plant location, following points has to be kept in mind. No plant can be located at a place which fulfills all the criteria of perfect location. Some factors are to be compromised to make advantage of the other factors. If raw material is quite bulky and difficult to transport, the plant must be located near to raw material sources, like we can take the example of Jamshedpur, Bokaro, Rourkela, and TP. With this, we will be concluding today's session, and we will be continuing with the same topic in the next one.